Hey everybody, Mr. Walker here, going over another lesson in career explorations. This is the last one for this unit. This is Unit 4, Lesson 6. This one is expanding upon the architecture and engineering careers. It is titled Science and Math. Science and math is a big subject, right? We've already been over a little bit of what STEM is, right? Science, technology, engineering, and mathematics. These are jobs that are high-level math, high-level science. They really kind of they cover a lot of stuff, man. If you're going to design something, if you're going to build something magnificent, if you're going to invent something, most of the time, this is where that stuff lies. Because you can't just conceptualize something and then poof, here it is, right? You got to prototype it, understand mechanically what it's going to do, know what pieces it's going to be comprised of. You've got to arrange suppliers to provide those pieces. There's a lot to it. I mean, there really, really is. And so science, technology, engineering, and math careers are growing very quickly. And as I've already said before, the biggest thing about these careers, the reason they're so critical, if you have a career in one of these fields, you can't be replaced by a robot. One thing that robots absolutely lack the ability to do is to create. They don't know how to invent something from nothing. You can program them to repeat a task a million times, okay? If you want to make a burger flipping robot that flips a burger 1,000 times, it's easy. If you want to create a robot that's going to look at information and say, well, based upon what I'm seeing here, we need this item, they're going to fail. They can't do stuff like that because robots don't have creativity. They don't have that human spark of conceptualizing and visualize something that doesn't exist. Robots can't do that. And that's where science, technology, engineering, and mathematics careers really thrive. So let's talk about what there are here. The supporting careers for these, okay? Because obviously these guys can't do it all on their own. So you've got to have a little bit of help. So the very first thing we talk about is, I believe, technicians. Sorry to scroll too far. Just like engineers have technicians to help them, okay? Scientists also have technicians. An engineer can design stuff, but they're going to have people helping. They're going to have people that will draw it out, drafters. They're going to have people that work out the mechanics of it. And scientists have the same thing. Scientists can't do all the work themselves. Most of the time, scientific technicians are grad students, people that have finished a bachelor's degree, have a good foundational understanding of science, and are now working on a master's degree, a doctorate degree, whatever. And those people will assist the scientists with their work in order to take some of the burden off, because there's too much for one person to do. That's what technicians do. The university technicians, most of the time, are going to be grad students. It's a way to pay for your education. If you want to go down this rabbit hole and get yourself a doctorate, a lot of people do exactly that. Okay, they go through and they act as a technician and supporting roles. When I was in my undergraduate degree, I started off studying biology, specifically marine biology at UC Santa Barbara. And through that course of study, in my first year, because I was doing well in chemistry and such, they invited me to work in the lab with some other grad students and titrate samples of algae. And I went in there all pumped up and excited, thinking, this is going to be great, man. I'm doing like real science. And I started doing the real science, sitting in my lab coat by myself for hours at a time, noting the results on a little piece of paper when I added this or added that or whatever. And I was bored out of my mind. And that's when I changed my degree in English, because I was terrible at that. That's a different story. My point is, had I not taken that opportunity to participate in those classes, I could have very well chased down a degree in marine biology, which probably wouldn't have been something that I would have liked. I will encourage you. They talk about CTSOs a lot in this class, right? Career Technical Student Organizations. Make sure you take the opportunities that you can when they're presented. If you think you love something, get involved with it. Go find out. Maybe you don't. I've had a lot of friends over my life that think, oh man, I love working with animals. A big part of working with animals, especially if you're a veterinarian, is unfortunately putting them down. And if that's something that you can't do, what are you gonna do? You have to. That's part of the job. It sucks. Part of the job. You should know the job. Sorry, I'm off a little bit. Talk about the other things here. Chemists, forensic scientists, atmospheric scientists, and biologists. These are all pure science careers. These science careers, basically, you're going to be doing something in a classroom, in a laboratory setting. You're creating new data for people to study, okay? This data is going to be used to develop something, to build something. Biological study, one of the things that's going on right now, guys, is between chemistry and biology, they're trying to develop a cure to this crazy illness that we've got, right? They're trying to build a vaccine and medications that will eradicate it so that people don't die. This is a complicated task. There are literally, right now, probably several million people working on that task around the world. That's a lot of people. It's not simple. If it was easy, it would have already been done by now, right? Easy stuff is figure out how to make this chair not sticky. Okay, we'll put a coating on it, makes it not sticky. That's easy. Working with humans, working with biology and figuring out how to solve those big problems, that's tougher. And so that's what these jobs are. Chemists, atmospheric scientists, biologists, all these people are working with pure science, trying to figure things out. The other one that they mentioned here, forensic scientists, you guys have watched like the crime shows and stuff. A forensic scientist is somebody who tries to figure out what happened after the fact. If you walk into a room and there's a body over there and something bad's happened to them and there's blood over there and there's a footprint over there, you're trying to figure out what happened because you weren't there. There's not necessarily video footage of everything, so you're trying to figure out what happened based upon the things that you see. It's an interesting career. Be aware, that's another one though, that don't get into that and be a little bit squeamish. Don't be afraid of a little bit of bad stuff because you're going to see bad stuff. That's the nature of it. Get into your head. Every job is going to come with a couple of good and bad things about it. These are all jobs that take really good degrees, at very least a bachelor's, a lot of times more than that. Going down here, mathematicians and statisticians. These are jobs that you would be stunned at the amount of math that they use. So I'm working on a graduate level program myself right now, and one of the things that I had to do is a class on education research. So here's what a mathematician had to do for some of the stuff that I had to read. They took data from thousands of students across multiple schools, and they pooled all the data together, and they drew means and averages and affectations based upon this variable and that variable, and they calculated charts of predicted results. How? If I'm perfectly honest, I don't know. I don't get that kind of math, but that's what they do. Mathematicians and statisticians work with very high-level math, and they try to predict things that are going to happen based upon mathematical norms. Very cool field of work. Other things that use this, insurance companies use what are known as actuaries. What is an actuary? An actuary makes a prediction of how likely an event is in order to happen so that they can figure out what level of risk the company has. Insurance companies use them because if they're going to insure you, little Billy, who isn't a very good driver because you're brand new, they need to know how likely you're going to crash. How do they figure out how likely you are going to crash? They look at everything. They look at average of grades in your area. They look at the car that you're going to drive, how often that car is involved in an accident, how often your age group's involved in accidents, your family history, whether or not you've been responsible in the past, how good were your grades, et cetera, et cetera, et cetera. And then they give a calculated risk and say, this is how much money we got to charge these guys so that we don't lose money on their insurance. That's an actuary, okay? Mathematics and statisticians do all of this stuff. Other pure scientists down here, anthropologists, archivists, and archaeologists. All of these are dealing with old stuff, okay? An anthropologist is specifically dealing with the changes of human beings over time. A long time ago, probably, we were cave dwellers. Now we're not. A few hundred years ago, the average person was like 5'7". Through better diets, through more exercise, through better science, the average person now is closer to 6 feet. Why? Anthropology. People change, okay? Archivists look at old documents, okay? They look at something that was written 1,000 years ago, 2,000 years ago. What did this mean? Why did they write this? You know, taken out of context, the Declaration of Independence doesn't mean much, but knowing exactly what was going on at that time gives that document a lot more background knowledge so that we can say, I see why they did this. The taxation thing really got to them at a certain point, but they've got higher taxes now. Yeah, but they say they chose those taxes. That's different than having them imposed by the guy across the ocean. An archivist is going to look over documents and know what's gone on in the past. Why did they make this document? Why did they write the Declaration of Independence? Why was the Bible written? All of these things are what archivists are going to study, okay? The last one, archaeologists. Archaeologists do the same thing, but instead of it being documents, archaeologists are studying old items, right? An old spear, an old helmet, a burial mound of ancient people, whatever that happens to be. An archaeologist studies those relics and makes sure that those relics are understood. Why do we need to understand that? Because people who do not know their history are doomed to repeat it, okay? There are some great civilizations that have come before us. There are some great civilizations that will probably come after us. We need to know what mistakes they made so that hopefully we don't make them as well. So that covers those. The last bit here, working in these careers. STEM careers are growing quickly. Again, they're growing quickly because you can get machines to do this type of stuff. It takes people to get out there and examine it and do the math and do the science and figure out why did this happen? What connects this to this? Robots just can't do that. Someday, who knows, maybe. Today, no. And I don't see that happening anytime in the near future. Be aware, you're going to need to get involved with science technology. If you hate technology, if you hate your science class, if you don't like doing math, these careers are going to challenge you because you have to use high-level math and high-level science within them. You also might want to chase down a CTSO that is about this. They specifically say the Technology Student Association is one that's out there. I don't know if we have a chapter of it, but I guarantee you the internet knows. So that's it. That wraps up this unit. 2 major fields, okay? Architecture and construction, the building of buildings, and engineering, technology, science, and math, the pure sciences. These are 2 things that are very interrelated to one another. These are 2 things that pay very, very well. And they're things that are growing. They're not going away. These are things that are worth considering. So that's it. That concludes this lesson and this unit. I have absolutely enjoyed everything that I've taught you guys so far. I wish you the best of luck, and I shall see you sometime.